Dear students, welcome to my channel. Topic of this video is diagrammatic representation of the data for 2D, 3D, pictogram and cartogram. Types of diagram: one-dimensional diagram, that is bar diagram; two-dimensional diagram, that is rectangle, square, circle, pie chart, etc. Three-dimensional diagram, which includes cubes, cylinders, spheres, pictogram and cartogram. In my previous video, I have already explained one-dimensional diagram, that is nothing but the bar diagram and its variety types in detail with the example. In this video, I am going to cover 2D, 3D, pictogram and cartogram respectively. Two-dimensional diagrams. It is also called surface diagram or area diagrams. In contrast to one-dimensional diagrams, which only consider the length of the bar, two-dimensional diagram consider both length and width of the bar. As a result, the area of the bar represents the given two-way classified data. The following are the types of two-dimensional diagram: rectangle, square, circle, pie diagram or pie chart, or it is also called as a sector graph. Rectangle. Area of rectangle is equal to length into breadth. Rectangle diagram is drawn by taking one of the two variable as length and another variable as breadth of the rectangle along two axes. For example, the identical product is produced by firm A and B. In January 2011, the company A produced 200 units whereas company B produced 400 units over the same period. For companies A and B, the cost of the production per unit was 10 and 8 respectively. We have to show this fact using the rectangle diagram. Now for firm A, area is equal to 200 into 10, where 200 is nothing but number of units produced by the company and 10 is nothing but the cost of per unit. Therefore area is equal to 2000. Similarly for firm B, area is equal to 3200. This is the representation by using a rectangle. Now this is the firm A, firm B. Here length represents the number of units produced by each company. So here A company produced 200 units while company B produced 400 units. Now here the cost is different and cost is represented by width. So here cost is 10, this is nothing but by this width, and here the cost is 8 and this is nothing but represented by this width. So it is nothing but the multiplication of length into breadth which gives out the area. Now see the second example. Here the firm A produced the 400 units over the 3 months while the firm B produced or firm Y produced 800 units in 2 months. Now here the duration is not same. Here duration is for 3 months and duration is for 2 months, and here the cost of the product is same but the duration is different. Now here the area comes as 1200 and here area comes as 1600. So this is nothing but the length, that is number of units produced, and width is nothing but the duration. Here 800 units produced by the firm Y and the duration is of 2 months. So in this way we can represent the data in rectangular format. Square diagram. When there is a wide range of values among the given numerical value, a square diagram is preferable over a rectangle diagram. For instance, company A and company B sold 20 and 240 goods respectively. So here the figure changed drastically from 20 to 240. For simplicity, even we take the 1:12 ratio, that can be also used, but even we use original or the ratio, diagram appears narrow. To overcome this, we calculate the value square root before selecting a suitable scale to represent through square. Now see this example, that years are given, that is in a interval, that is 2000 to 2005, 2005 to 2010, 10 to 15 and 15 to 20. So number of colleges are 4, 9, 36, 64. Now we can take, for example, here there is a drastic change. Initially value is 4, then 9, 36, 64. For simplicity, I keep the small values because it is very difficult to represent on the screen. Now here we take the square root of this number, that is 4 square root is 2, 9, 3 and 36, 6 and 64, 8 respectively. Now in square diagram we represent by the square. Now here the first, it is square is nothing but the 2 into 2, 4, that is area is 4. So it is nothing but the square of side 2. Here we keep some gap to not to overlap the squares with each other. After that again here the area is of 3, so 3 into 3. So on the x and y axis we are taking that respective area, a respective side, and we are multiply. Next is 6 into 6 36, and 8 into 8 64. So in this way we can represent. Sometimes it may happen that the values of square roots are also very large, so sometimes we can use a scale. Now here the years are given and number of ice cream shops. So now number of ice cream shops are 36, 64, 100 and 144. We can take the square root, but sometimes it may happen that even with the square root values are large, so we can use a proportional scale. Now here the scale is used, in which we divide the number by 3. So here we are getting the answer to 2.67, 3.33 and 4. And here we are drawing the square area with respect to it by taking the side scale equal to this value. So here 2 side and 2 side, their multiplication is equal to 4. So this is nothing but the area of 4. So in this way we can represent by using a square diagram. Next is a circle. The area of circle is proportional to its radius. Circle can be used in all those cases in which squares are used. In both types of diagram, it's very difficult to judge the relative magnitude with precision because we are changing the original values. Circles are difficult to construct, interpret and compare. It is not popular in statistical work. For example, see, years is given in that particular range, and after that the next is the garden area, which is given in hectare. So it is 3.14, 12.56, 28.26 and 50.24. Now here we will consider this formula of circle, that is area is equal to pi r square. Now a is given, for example 12.56. We will calculate the radius. So here the radius is 2. For simplicity I am taking the values like 1, 2, 3, 4. Now here we require to draw the circle, and in which again we require give some space to understand. Now here when we draw the circle, it's having the radius 1, it having the radius 2, 3 and 4 respectively. So in this way we can represent using the circle diagram. Also when radius becomes large, at that time we can use a scale. Now here the commercial complex and the area is again in hectare and the values are large. So first we calculate the radius, and if radius is large and it is not possible to present on the paper or slide, we will again do the scaling. So here scaling by 10 is taken. So 1.5, 3, 4.5 and 6 values comes into the picture. So here we are just representing by this particular radius of that value. That's why we are not getting the original values approximation, because here the original value is 11304, but when we draw the circle the value become the radius of 6. So here that is that they are difficult to construct, that is okay, but it is very difficult to interpret and compare because we can change the magnitude with the we make the conversion from one value to another. Next is pie diagram, chart or sector graph. It is used when it is necessary to understand how something's parts and whole relate to one another. That is, pie chart shows us how something total composition is broken down into various sections. For instance, if family total monthly expenses is 2000, they might spend 250 on food, 250 on education, 100 on rent, 150 on transportation and 300 on other products. It gives that family spends 25%, 20%, 10%, 15% and 30% of their total income on food, education, rent, transportation and other expenses correspondingly. Now here we convert this problem into percentage problem. So when we make the addition of this percentage, we are getting the 100% as a final total summation. For example, when the amount spent on food is increased from 25 to 30%, then the percentage of other heads must decrease to keep the total as 100%. Similar to this, if spending on one of the heads reduce, the percentage of the another head must be spread to keep that total at 100%. So when we require to take this study, that the study of something that is part to whole, at that time we are using the pie diagram. Pie chart shows the relationship between the whole and its component. Now in pie chart we are representing the total quantity. In percentage it is represented by 100. In pie chart we are representing the total quantity by 360. 1 unit of quantity is represented by 360 divided by total quantity. and given quantity is represented by 360 into given quantity divided by total quantity. So this is the simplest simple mathematical formula. If components or subdivision of the quantity are given in percentage, then the angle of the sector will be calculated as 360 into given quantity divided by total quantity, and in terms of percentage it always comes as 100. So formula is 3.6 into given quantity, or we can divide by 100, so one and the same things. Now see this example. The total amount is 1000. Amount is distributed to 5 friends in percentage 25, 20, 10, 15 and 30. Draw the pie chart. So this A, B, C, D friends are there. Then this is the percentage. When we make the addition, it becomes the 100%, and now we require to represent this value into 360. So 100, total 100 we require to map to the 360. So pie chart angle is equal to percentage divided by 100 into 360. Now when we say the percentage, our divide factor becomes 100. So here 25 by 100 into 360, we will get the angle 90. 20 divided by 100 into 360, we will get the angle 72. So in this way we are getting the pie chart angles. Now see the next example. In a class of 60 students are there. Student having the interest in the following sports. Draw the pie chart. So these sports are given. 1, 2, 3, 4, 5 sports are given. The number of students who are interested in that particular sports. Now we require to calculate the angle. So here we require to, as percentage is not given, so we require to do that 10 by 60, because total 60 are there, into 360. So we will get the 60 angle. 13 by 60 into 360, we will get the 78 angle. So in this way we are calculating the pi angle. The same example, that is A, B, C, D students are given, and this is nothing but the number of students, and we can easily calculate the angle, pie chart angle for this problem. Limitation of the pie diagram. For accurate reading and interpretation, particularly when data are divided into large number of components or the difference among the values of the components is very small, the pie diagram is less effective than the bar diagrams. Attractiveness of pie chart suffers if the number of parts of the whole is more than 7 or 8, because at that time partition will be large and whatever that separation will be very small, so it is very difficult to interpret. In terms of comparison, the pie diagrams appears inferior to the bar diagrams or divided bar diagram. Pie chart is used only when total of the parts make a meaningful whole. Pie chart should be used if observation of the different parts are mutually exclusive. Pie chart should not be used if the observation of the different parts are observed at different time. So we can't take the time vary data, that is the time series data for the pie chart. Now see the next topic, that is the three-dimensional diagram. These diagrams are three-dimensional in nature, that is having length, width and depth. The most common types of three-dimensional diagrams are spherical, cubical and block pile diagrams. They are also known as volume diagram. These diagrams take up significantly less space than the two-dimensional diagrams. As a result, they are particularly effective when the values of given quantities are vary widely. These diagrams are also used on distribution maps as a location diagrams. Now here we can see that this is the Mexican population, that is a map of Mexico, and in that different states of the Mexico are shown and the population is shown. So here we can easily identify by seeing the size of the sphere. We can take the estimate for the population size by seeing the size of the sphere. Spherical diagram. It is also called as graduated spheres. A sphere that is geometrical figure which has a minimum surface area in proportional to its volume. They are especially useful when the variation in the quantities to be displayed are significant. A sphere, on the other hand, cannot be subdivided and cannot be display quantity components. This is a very important point to understand. So it will display the entire quantity as a whole. For example, it can depict only the entire population of city but not its male, female or illiterate, literate component. Now see, this is the population diagram for the different cities. So Mumbai, Pune, Nagpur and Kolhapur, the spheres are shown. So by this way you can easily judge that the population of Mumbai is more compared to the other cities. Now here the formula is to draw the sphere of that particular radius. Required radius is equal to assumed radius into cube root of given figure divided by assumed figure. So this is taken based on the size of our paper or the size of the slide on which we require to draw this particular sphere of the radius. Suitable scale is selected to draw the sphere based on the size of the paper and numbers. For example, here we can take that 1 centimeter radius of the sphere is equal to for the 50,000 person, but it is not fixed. It is depend on whatever the values in table we have, and based on that we can select this 1 centimeter radius of the sphere. For example, these 5 districts are shown: Thane, Pune, Nashik, Nagpur and Kolhapur, and this is their population. So first we require to calculate the required radius. Now here we are taking the 1 centimeter is equal to 50,000 person. So what we require to do here, assumed radius we are taking for simplicity 1, so it is nothing but the scale value. So assumed radius is 1, so we require that whatever that given figure divided by assumed figure. So given figure is given this, for example 11060148, and it is divided by 50,000, and after that we will take the cube root, multiply by the proper scale. So here scale is taken as 1 and we are getting the answer as 6.04. So based on that we can draw the various pairs. So when we draw 65444, so here we get the variation in the, so for simplicity I am taking very the range of the values is not drastic, but when we take the range of the values which is very drastic in nature, we can easily find out the difference. Now here for example the crops, 3 crops are given: rice, wheat and sugarcane, and their production. So here also we can take that particular, that is 1 centimeter is equal to 50,000 as a unit of production, and after that we first take the cube root, multiply by the scale factor, and we are getting the radius, and based on that here we are getting the radius 23, 13 and 7. Now compared to first data, here more variation is there. So when we draw the sphere, we are getting the sphere of different radius, and from that we can get the idea. But here only we are getting that idea that how much quantity is there, but if we want to calibrate again it at a different level, we can't do that. Then next is the unit blocks and pillars are arranged. These are also 3-dimensional diagrams and mostly they are used in a geography. So unit blocks and pillars are arranged so that incomplete pillars are always in front. For example, this is the pillar of 0.2, this is 1, so it is 16.5, so this is nothing but the complete 10, and this is 6.5. This is 23, 10 plus 10, 20, and this is 3, 77, so all these are 60, this is 70, and this is half, that is 7 totals are there, 77. So in this way we can represent the 3-dimensional diagram using the unit blocks and pillar. This we already studied in that OLAP tool, that is online analytical processing. At that time we are representing the data in multi-dimensional. So for example here 3-dimensional data is given, that is the quantity, then quarter and the years are given. So in this way also we can represent, so these are nothing but the cubes. So in this way also we are representing the data in 3-dimensional way. Fourth is pictogram or pictograms. Pictograms are created by using pictures. These diagrams point to the nature of the facts represented. Pictograms are visually appealing to and simple to understand, and making them ideal for presenting the statistics to the general public. The image that used as a symbol to symbolize the units or values of any variable or commodity is carefully chosen so that everyone will get the idea of that particular symbol. The visual sign must be self-explanatory. For example, to show the increasing number of trees because of plantation drive is represented through the tree symbol. So we will show that how many number of trees increases for that particular year by using the tree symbol. Now such different types of symbols are used. For example, some of the symbols are from the figure also you can easily guess. So this is nothing but again the pictogram, and here for example this key, that entire star is nothing but 8 points. So here we can easily get the idea, it is nothing but 8 plus 8, 16 and plus 4, that is a 20. So in this way we can represent the Pictogram. So every time it is not necessary that we can represent the values using pictogram. Some symbols are universally accepted and they are common everywhere, so we can get the idea. So these are nothing but the advantage of pictogram. The magnitude of the variable may be known by counting the picture. Illiterate person also get the information. The fact represented in pictorial form can be remembered longer. Gives only the overall picture but don't give the minute details. And for greater accuracy, we should write actual figures under or above one side of the symbol. Last is cartogram. Cartogram refers to the representation of numerical facts using a map. The impact of the outcomes on different geographical areas can be demonstrated and compared by showing the data with maps. Maps are useful for comparing different districts of a state or different states of a country. For example, the production of wheat in different geographical area can be represented by using the cartogram. So cartogram are very useful in the geography. The quantities on the map can be represented in variety types of way, including the shading, color, dots, or placing pictogram in each geographical area or the proper numerical figure in each geographical area. Now here, this is nothing but one example of pictogram. Here we can see that different countries and that population is represented by the number, so we can get the idea that different countries and with that particular their population. Here for example, the literacy rate in India, so different states are given. Now here for each literacy rate they are using the different colors, so from that color we can get idea for that how much percentage of literacy is there for that particular state. For example, this is nothing but the different states and density. So here also they can use a different variation that that is, for example, this is for 151 to 50 to represent the particular density region. So these all are nothing but the example of cartogram. Now this is nothing but the, for example, comparison between 1991 and 2001. So this is nothing but 8 direction, that is north, south, west and east, and again the 4 sub directions, and they are given the detailed minute. So from that we can easily get the information that there were 865 girls for every 1000 boys in Delhi in 2001, and in 1991 it was 915. So there is a the girls number of girls are reduced from 1991 to 2001. So this is nothing but again one of the example of cartogram. So this is nothing but all about, this is one more example that is of the states of the USA, and in which we can find out the production, and based on that we can also find out the variation in color. So when the production is more, the color is get darker. So this is one of the way. So these are all examples of cartogram and by which we can explain. Thank you.